Hello grade 10s and welcome back to this series on particles substances are made of. In our previous lesson we studied ionic compounds. We saw that ionic compounds, like metallic compounds, have their particles arranged in a crystal lattice. In today's lesson we will have a look at the arrangement of particles in covalent compounds. In the topic on chemical bonding, we learned that covalent bonding occurs as a result of electrons being shared between atoms. This clip shows the formation of the fluorine molecule F2. Each fluorine atom has 7 valence electrons and the two atoms bond to form a shared pair of electrons between them. Let us now look at how covalent compounds come together in a lattice. We will look at the silicon dioxide molecule. SiO2, silicon dioxide, is all around us in the form of sand as well as quartz crystal. Let us now have a look at some models.
In a quartz crystal, silicon combines covalently with oxygen to form a giant molecule. Inside this molecule, every silicon atom is bonded to 2 oxygen atoms in a spiraling ringed pattern. This bonding is not based on electrostatic forces of attraction, but on the sharing of electrons between the different atoms.
This is a model of the silicon dioxide lattice. The large green circles represent silicon atoms and the smaller red circles represent oxygen atoms. Let us go to the lab and investigate some more compounds containing non-metals.
Hi guys, have a look here. In here I've got solid white phosphorus. Inside the solid there are molecules of phosphorus held together by intermolecular forces. The phosphorus is quite soft and I can cut it easily. Now this should tell you that the intermolecular forces in phosphorus are not as weak as the ones found in gases and liquids, and that are not very strong either, like the ones found in very hard substances. Now you must be wondering why I've been working with the phosphorus underwater. Well, phosphorus in this form reacts very quickly with oxygen. If I take it out of the jar, it will start burning in air all by itself. And the reason for this is because a phosphorus molecule is made up of 4 phosphorus atoms covalently bonded together. The atoms are squashed together in this arrangement and are under lots of stress. By reacting with the oxygen in air, a new, more stable compound forms. Now, this is solid sulfur. It is brittle and can be very easily ground into powder. Now, can you see that there are clear differences in the physical properties between sulfur and phosphorus? Now we can actually use our model of the molecules to explain the differences. Inside sulfur, we see molecules of 8 sulfur atoms bonded together covalently. The sulfur molecules are held in place by strong intermolecular forces. The molecules are placed in a particular pattern that builds the crystal structure or lattice. Now notice phosphorus molecules have 4 atoms squashed together, while the sulfur molecules are made from 8 atoms joined in a bent ring. The sulfur ring is much stronger than the molecule of phosphorus. The intermolecular forces in sulfur are stronger than in phosphorus. This explains why sulfur is stronger and harder than phosphorus. The difference in intermolecular forces is also the reason why phosphorus has a low melting point than sulfur. The forces in phosphorus are weak and can be broken easily by heat. Back to you, Diasha.
Thanks, Aaron. You know, this property of having a low melting point is something that is quite common in nonmetals. But there's one non-metallic solid that resists heat, and that is a diamond. Diamond is one of the hardest materials around and is used in glass cutters and grinders. What is so special about this material? Diamond is a different structure to phosphorus or sulfur. It is a giant covalent structure. Deep inside this diamond, we see many carbon atoms all linked together. This link, though, is a covalent bond, not a force. A covalent bond is much stronger than an intermolecular force. The carbon atoms are arranged in a tetrahedral shape, each one covalently bonded to the next. Atoms of carbon are added and added covalently to form this huge structure. When diamonds come out of the ground, they look like a dull piece of rock. In order to look spectacular and shiny, they have to be cut and polished. So, how do you cut this massive structure? Let's speak to an expert to find out.
Diamonds are all unique. Each and every stone is unique. So the treatment is also unique. But to generalize, first of all, one opens up the diamond. That means we polish a small window on the diamond. We call it a window. It's a small facet, maybe 1 millimeter square, that allows you to look into the stone, because most stones comes with a bit of a skin. And then you decide how to maximize the value of the diamond. Now, in most cases, the diamond comes in this shape. We call it the octahedron shape. You see, it's 8-sided. It looks like 2 pyramids. Okay. And then, once you've decided to maximize the value of the diamond, one would mark the diamond with a black ink pen. Once you've done that, you've completed the first step. The second step in diamond processing would be the sawing process. Now, imagine you've got the octahedron, okay? We would then saw the diamond in 2 pieces. So the next step in the process will be the bruting or cutting process. That means we're going to make this diamond round. The way we do it is we put this in a bruting machine, the one end of the bruting machine, and we fix this piece to a stick. And then while this is turning in a bruting machine, very much like in a lathe in the engineering shop, we hold this with a stick towards this one, so the one diamond cuts the other one around. Because you must remember one thing, the diamond is the hardest substance known on earth, and nothing cuts a diamond except another diamond. So you've got to use both pieces to end up with something like this. Once you've done that, you've completed the second step in diamond cutting. Now, the third step is we start polishing the diamond, and we start with this facet. We call it the table facet. Okay? It's the big facet. And then we add to it 4 more facets at the back and 4 more facets at the top. This process is called cross-working. It's finished once we have got 9 facets on top and 8 facets at the bottom. The cross refers to this shape, 4 facet shape. Then, once that's done, we've completed the third step. The next step would be to brilliantier. Now, that's adding another 40 facets to the stone. We call it upper girdle facets, 16 bottom girdle facets, 8 star facets. So you end up with 57 facets in total, and that completes the process.
That was very interesting. Let us recap what we have learnt about today. We have seen that covalent compounds can form smaller molecular structures such as P4 and S8, and that they can also form much larger network structures such as a diamond, whose structure we see here in the footage. We have reached the end of today's lesson. You can also find out more information on this topic at www.mindset.co.za/learn. That brings us to the end of the series on particles substances are made of. Make sure that you attempt all the questions in the task video. Until next time, goodbye.